So last video, I tried to introduce logarithms, and I also attempted to explain the first log property right here that I may or may not have done very clearly. But more generally, the property that I was trying to introduce was log base b of b to the power of c is equal to c. So that's what I was trying to do. That's my last video. That was the introduction. Now here in this video, we're going to talk more about log properties, as you can see here with this thing and these two weird things, right? So before I do that, I'd like to talk a little bit. I'd like to try to re-explain what I tried to explain in my last video with this property, right? And I'll do the same for this property. So basically, for our first property, log base b of b to the power of c is equal to c, right? So if we take a look at the logarithm, what we're really asking, I'm gonna put a semicolon because that's cool. What we're really asking is b to what power, right? B raised to what power is equal to b to the c power. Right, that's what this log is asking. So you look at it and you think, all right, this b and this b are the same, so this unknown power must also be equal to c, right? So that's how you get c right here. Now for the second one, let's focus on the actual exponent, the log exponent, right? So I'm putting a semicolon because that's cool, right? So the log is asking b raised to what power is equal to c, right? We see b and a c and we don't really know anything. So, I mean, I don't know. It's probably a number, right? I don't know what number it is, but it's probably a number. Oh, look, we raised b to that same number, right? So we're probably going to get c again, right? Because b raised to what power is equal to c? Some number. Oh, okay, hold on. Let's raise b to that same number. We're probably going to get c again, right? So that's how these two work. Now this one, this log property, it's kind of like the exponent property, right? Where you multiply two exponentials, or if you want to call it that, multiply two exponentials, and you can just add the exponents, right? That's kind of like this one. You can multiply two numbers in the argument, and you can just break up the log by saying, like in this case, if I have log base b of a times c, right? Then I can just break it up, right? Log base b of a plus log base b of c, right? So it's kind of like the exponent product rule, right? In this one, I mean, multiplication turns to addition, so division must turn to subtraction, right? So this is kind of like the exponential division rule, right? Where you have two exponentials, right? Like one in the numerator, one in the denominator. You can just subtract the exponents. That's kind of like that. So really not that bad. These two should be straightforward. Hopefully my explanation made sense. These two, they're kind of like exponent rules, right? Just more logified. And now, it's really a short video, so I'm going to end it with a question. Well, I'm going to end it with another property, actually. So that property is, oh my goodness, my marker. Log base b of some a to the n is equal to n times log base b of a. So I'm going to end with this property. And my exercise for you, what I want you to do is, knowing what exponentiation means and knowing all the other log properties I told you above, I want you to prove this and tell me why this is true. Because this is a log property. This is a real property. This is one of the top 10 properties of all time, right? I want you in the comment section, or maybe in a response video, whatever you want to do, right? I want you to tell me why this is true. So that's your little exercise. That's your homework. Actually, I don't like giving homework. This is your little exercise. This is your little challenge for the day if you choose to take it or whatever. I don't know. But yeah, this video is about simple log properties. These are really the main log properties, and these will be useful for solving equations involving exponentials and unknown exponents and other crazy stuff. So might do something about that, might solve some exponential equations in the future, but I can't predict the future, so stay tuned for whatever I post next.